But that just means, and it did ask for the amplitude, so make sure you read that. So you would have to put the amplitude is a positive 2. And most of the time when I want to know the amplitude, it's going to be a problem like this, because I don't want you to put negative 2. So on a test, if you put negative 2, you lose points. Amplitude is always positive, so you have to put a positive 2 for amplitude. If you look, it does say identify the amplitude. All right, so we have amplitude of 2, and it's going to go right pi over 2 units. Well, it's cosine. Maybe I should mark this. I'm going to mark this 1 and negative 1.
Is that called positive?
Yes. I would have caught it when I graphed it, but not there. All right, then we have 2. All right, so cosine. Cosine usually starts here, goes down, 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 down. And in fact, I'm going to graph it. I'm going to graph just the standard cosine. So that's just a regular cosine x. Now the amplitude is 2, but on top of that, it's a negative 2. So rather than being up here, it would be down here, and it's also going to move left pi over 2, so it's going to be right here. I'm going to actually do all 3 of these. So first of all, this is going to be the next step. So that's with the reflection and the amplitude. I just didn't shift it left yet. Now I just have to shift it left. And that purple one is the final. That is my final one. It is flipped. The amplitude's 2, and it got shifted left pi over 2 units. Does anyone disagree? All right, then what questions do we have from the homework? If no one disagrees with my answer. Yeah.
What do you mean by more points? Like more like.
Oh, for you specifically?
Yeah.
I mean, I should see like 2 pi. I should see all these. I should see at least 4 of these markings where we have, pi over 2, pi, 3 pi over 2, and 2 pi. You'll know a little more today because I'm going to say why it's so important that you do that in the next section right here. But you do need to mark at least 4 of those points on the x-axis. Other questions on the homework? Okay, then let's get into today's lesson. Yesterday we talked about what happens when we change A, change their amplitude, or it flips it. Then we talked about C, which makes it go left or right, depending. And we're going to start out with talking about B, this B value. But here's something that's really important. Here's something that's really important that's going to pop up its head in a little bit. See this x minus c? In order to determine if it's going left or right, it has to be x minus or plus a number. Note our b values on the outside of the parentheses. If I'd cover this up, we're still left with quantity x minus something. So this b value has to be on the outside, and if there's a shift, it needs to be x minus or x plus, and it'll make more sense when we get to a problem where it's not correct. In this case, we don't have to worry about it because whether I have parentheses or not, it's just a 2 right here, and we have a 3 out front. So right now, our amplitude is that 3, and the period is going to be 2 pi over whatever this b value is. So it's 2 over this 2, which actually just equals pi. Now the period of a sine or cosine function just basically tells you how fast it's going to complete one cycle. So Yesterday's, all the graphs took 2 pi to complete an entire cycle. It started at 0 and it ended at 2 pi. This one's going to start at 0 and end at pi. All right, so it's going to go like half the distance to complete one full cycle. So if we wrote this like normal, this is 2 pi out here, and this was pi. We'd have to write the entire cycle in here. We don't want to do that. It's kind of like when you have a graph, you change the scale depending on where you're zoomed in on. You're not going to count by ones if you need to get up to 1,000. You're going to count by hundreds or something like that. So when we're doing this, we're going to change this scale depending on the given period. And that's what this says up here. You must change the units of your x-axis to match the new period. It's going to make your life a lot easier. I'm going to show you kind of a shortcut to do this. So this is my little shortcut to making your life a little easier. All right, step 1 is find the period. We already did that. Step 2, mark what you found 4 ticks away from the origin. So you are going to mark that period basically 4 units from the origin. Mark the period 4 units from the origin. Now what that means is, so sometimes I leave it blank. You have to make your own tick marks. All right, but this one already had tick marks. So you go 1, 2, 3, 4, and actually write the period that you found right here. So we're going to write pi right here. So you count up 4, and you just mark whatever period you had. Yesterday it was 2 pi that we wrote there. Step 3. It's going to seem weird until we see what happens. But we're going to divide by 2. Step 4 is going to be divide by 2. And I'll talk about what this means in a second. And the 5th step is just multiply by 3. Divide by 2, divide by 2, multiply by 3. I'm going to tell you right now, these steps are almost useless with this number, but harder ones is going to make it a lot easier. Yeah?
Is there any reason why we divide by 2 and 2 again instead of just dividing by 4?
Yes. Any other questions? No, I'm just kidding. We'll figure out why we do it in just a second. I'm going to draw a little picture off to the side, and then we're going to actually do what's happening. So let's pretend that we are just counting out 4 tick marks, and I mark my period there. So the first time we divide by half, I'm actually getting this value. This value. I'm getting this value right here. I'm just dividing by 2. It's your halfway point. So that's exactly what I'm saying. This is our halfway point. Then I'll take that number and divide it in half again. So this is half this distance. So I'm just dividing by 2 again. Then I multiply by 3 to get this third one. You'll hear me say it's half multiplied by 3. It's not that bad here, but on ones with weird ones, that's when you really need this. So what's happening here? See how we have pi units out? I want that halfway point, which is obviously pi over 2. If this is pi, the halfway point is pi over 2. But that really is just divide this number by 2. So we divide it by 2 and we put what we got there. So pi divided by 2. Then to get to this one, Daniel, you could divide by 4. You could divide by 4 and just go pi over 4, but sometimes it's just easier to half this number. If you're already on that roll, sometimes it's just easier to divide by 2. But if you divide by 4, you'll get that exact same thing. So if I divide pi over 2 by 2, you get pi over 4. These usually aren't the hard ones. Sometimes the hard one is this one. That's the multiply by 3. And why we multiply by 3 is, see how this distance is pi over 4? That means this distance is pi over 4, this distance is pi over 4, this distance is pi over 4. So we have 1, 2, 3 pi over 4s to get here. So that's why we multiply by 3 to get here, to get 3 pi over 4. As I said, this is probably not the best example, but sometimes your period is like 2 pi over 7. And it's just easier to go half, multiply by 3 rather than having to go, okay, what's 3/4 of 7 pi over, I forgot what I even said, but what's 3/4 of it? And you don't have a calculator, so you kind of have to do this quick math. All right, I like it. It's half multiplied by 3. And then as soon as we got this, we don't have to worry about the period anymore. The period is taken care of. Now we just worry about the amplitude. The amplitude is 3, and our function is sine. Sine usually starts at 1, but since the amplitude is 3, we're going to start at 1, 2, 3. So we start at 0, and we'd go up to 3, but I should probably mark my other side, -1, -2, -3. All right, so we start at 0, 0. Usually goes up to 1, but now we're going to go up to 3 because the amplitude is now 3. We come back down to 0. We go down to -3, and we go back to 0. So the period only dictates your x-axis. And once you fill out your x-axis, you don't have to worry about it anymore. It works the same way. That's why we do exactly 4 tick marks, because then we don't have to worry about it. Questions on that graph? I'll give you guys a couple extra seconds. I see some people still writing. Yeah. All right, the next one. Whoa. No, that's the right one. All right, the amplitude for this one is just that 2. The period is 2 pi divided by the b value, which is 3. Once I have the period, this is like the first thing you do every single time. Find the period and mark your x-axis. I count out 4 tick marks. 1, 2, 3, 4. And I actually write that period down. 2 pi over 3. Then I go 2 pi divided by 3, divide that whole thing by 2. And we can do the math down here. So we're going to do 2 pi divided by 3 divided by 2, which is going to be the exact same thing as 2 pi divided by 6. So this 2 and 3 end up just multiplying, which is just going to be pi over 3. But that makes sense. If I have 2 pi over 3, half of that's going to be 1 pi over 3. Then we take half of this. Pi over 3 divided by 2 is pi over 6. Pi over 6 plus pi over 6 equals pi over 3. Then the last step is multiply by 3. So I'll have 3 pi over 6, which is going to be pi over 2. Yeah, Brian. Oh, you had the answer?
Yeah.
I'm sorry, I stole your thunder. Hey, Brian, what's the third tick mark?
It's pi over 2.
Nice. And now we're done. So it isn't necessary to remember that half multiplied by 3, but on a test, it's a nice trick when you have a tricky period that you're just not sure what all, because you have to mark at least 4 of these on the test. So that's what I was talking about. On a test, you have to mark at least 4 of them for you to get full points on it. So I understand that you understand all those key points. All right, now we just have to mark cosine with an amplitude of 2. That means instead of going up to 1, we are going to go up to 2. Sine starts at 0, 0. Cosine starts up or down, wherever we are. So it's going to start up at 2. It's going to come down to 0. It's going to go all the way down to 2. It's going to come back up to 0, go back up here, and that is my 2 cosine 3x. Once again, the period only affects marking your x-axis. And then we just treat it like it's normal. All right, questions on that? The key to this is you have to know the shape of these graphs. You need to know the shape of these graphs because otherwise you've got to find the cosine of pi over 6, and that's even more values that you remember, versus just going, okay, our cosine looks like this, copy it down, left, right, up, down, stretch. All right, 5. 5 is our d value, which shifts up or down. The good thing of up or down is if it's positive, it goes up. If it's negative, it goes down that many units. Note, it also shifts your sinusoidal axis. This is like the first time you can actually see that sinusoidal axis, because usually it's just the x-axis. So let's look at this. It's a regular sine of x graph. So our amplitude is just 1 because it's the value that's out front. The period is 2 pi divided by 1 because there's a 1 out front, but that just equals 2 pi. That's why yesterday we didn't even talk about it. It was always being divided by 1, so it was always 2 pi. It is going to shift up. It's going to shift up 2 units. It's going to shift up 2 units. We have 1, 2, 3. So I'm going to show you kind of 2 ways to graph these. There's 2 ways to potentially graph this. The first way is to just graph sine and raise every point up 2 points. And that's what we're going to do on this first one. So a sine graph starts at 0, 0. It goes up to 1, goes back down to 0, 0, goes to negative 1, and goes there. So that's my boring sine of x. To go up 2, just shift all those points up 2 spots. That's it. So just shift all of your points up 2 spots. And that is my final graph. Put kind of a dashed line through it. That dashed line is your sinusoidal axis. Why am I noting my sinusoidal axis? Because on the next one, we're just going to use that to graph it. We're not going to shift all the points up 2. We're going to use the sinusoidal axis to help us graph it, because there's 2 different ways to graph. Pick whichever way you like. This is nice because you just shift all the points up 2. This one can get confusing, though, because you're doing a lot of shifting up points and you might miss something. So the other method I'm going to talk about is actually using the sinusoidal axis to do your entire shift for you. So we have 2 times cosine of negative 1. 2 changes our amplitude to 2. The period is 2 pi over 1, or just 2 pi, because remember, it's whatever number is in front of the x. That's a 1. 2 pi divided by 1 is just 2 pi. And then we're going to go down 1. Since we are going down 1, I'm going to go ahead and let's go ahead and mark this negative 1, negative 2, negative 3. Let's call this 1, 2. Since my sinusoidal axis is supposed to move down 1, I'm going to go ahead and draw it. I'm just going to draw my sinusoidal axis going down 1. Amplitude is 2. Amplitude is 2, and it's a cosine graph. So that means, sine you start at 0, 0. Cosine you start up or down. So since we're starting up or down, this is my sinusoidal axis. My amplitude is 2. I'm going to count 2 away from my sinusoidal axis. So my point's actually going to be up there. Then where cosine usually goes to 0, it's going to be 0 at your sinusoidal axis. So it's going to cross here. Then it's going to go 2 lower, 1, 2 lower. And we're there, back here, and we have, ooh, that got away from me. We have a graph that looks like that. Whichever method you want to use. I kind of like moving the sinusoidal axis because I know the general shapes of these things. So I just pretend, okay, I'm shifting everything. Oh, I can see that shape following that line versus the x-axis. If you're someone that wants every single point plotted, then you're probably going to pick that first method where you plot all your points, go up, do whatever you need to with them after. All right, questions on that? I'll give you a second. I see some people still writing. These are basically the steps to graphing. All right? Sketch one cycle of sine or that from 0 to 2 pi over b. What that says is find the period first and mark that. Find the period first and mark it. Change the amplitude of the cycle according to the value of a. If a is negative, reflect the curve across the x-axis. Translate the cycle h units to the right if h is bigger than 0, or h units, so we're going left to right. And finally, you go up or down. What's important about this, I don't really care what order you do this in, but I would save my up or down till the end. I would save that up or down till the end. Because if you ever have to do a reflection over the x-axis and you shifted it up, it's going to look like a weird graph that's wrong if you reflect it over the x-axis. Because you're actually reflecting it across your sinusoidal axis. So I would do my up and down last. That'd be the last thing I would do, just to keep everything straight. So the last thing I'm going to do is up or down. Otherwise, the other orders don't really matter. All right, so we have graph y equals cosine x minus pi over 4 plus 2. We're supposed to identify the amplitude and the phase shift. I'll probably identify more than that. Let's see. Maybe not. Our amplitude is going to be whatever number in front of that cosine, which is 1. We are going to shift right pi over 4 units. We get that from there. And it's going to go up 2. Let me get that from that. So tell me the period of this one. What is the period of this function? Yeah.
2 pi.
It's just 2 pi. There's no number in front of x. So it's 2 pi divided by 1. So it's just 2 pi. It's just 2 pi if you just have a 1 out there. All right, so we need an amplitude of 1, which is normal. We need to go right pi over 4 units. And we need to go up 2 units. So let's go ahead and label this as 1, 2, 3, 4. Negative 1, negative 2, negative 3, negative 4. So the first thing I'm looking at is we have to go right pi over 4 units. So I have to know what pi over 4 units is. Well, pi over 4 units is going to be half of pi over 2. Half of pi over 2 is pi over 4. So that's our pi over 4. So that means I should probably mark each of these halves, because that's how far we're moving. All right, so we're shifting right pi over 4, and we're going up. Well, cosine usually starts at 1. So we're going to go right pi over 4, and then we'll go up 1 unit. In fact, what would help me probably is rewriting the sinusoidal axis up. Oh, it's up 2. I'm sorry. What was I saying? Up 1. It's actually up 2. Because if I rewrite my sinusoidal axis, I don't have to worry about shifting it up anymore. It already happened. It's already shifted up. Now I have to worry about is the amplitude. Amplitude's 1, and our shift. We're supposed to go right pi over 4 with an amplitude of 1. So we're just going to start right here. It's a cosine, so we start high. So it's going to start right there. Then cosine always goes back down to the sinusoidal axis. Then it goes down 1, goes back to the sinusoidal axis, and it goes up 1. That's kind of a quick way to do 2 transformations in 1. Draw your sinusoidal axis. Know how far it goes over. Know it goes up 1, down 1. And as long as you know the general shape, it's not hard to do that. If you need to draw all 3 of them, if you need to draw cosine of x, it shifted up, it shifted right, by all means do it. All right, this is just a little quicker to redraw your sinusoidal axis and work from there. Doing okay? We're just doing one more. Just survive with me one more. We have to do this one because it's a special case. This is a special case, so is the next one. Why this is a special case is because if I look at this, in order for C to be a shift, it has to be x minus C isolated. X minus C has to be isolated. Right now, x minus pi is not isolated because it's actually 3x minus pi. So this right here has to be in the form b times x minus c. It has to be in that form. You need to be able to see just 1x minus or plus c. You have to be able to see that. And you can't see it right now because we have 3x. All that tells you to do then is factor out that 3. Bring that 3 out front. So to write it in that form, we're just going to bring the 3 out front. So we're going to factor out a 3, which means we're going to have 3 times x. And don't worry, when you factor something out, you're just dividing it. When you distribute, you multiply. When you factor out, you're dividing. So to pull a 3 out of here, just divide whatever's here by whatever you're pulling out. So I'm going to divide that by 3. So we have minus pi over 3. Especially when it's complicated, I just double check. All right, that'll be 3x. Yep, that'll just be pi. We're good. So you have to rewrite that. So this is actually going to be 2 times the sine of 3 times the quantity x minus pi over 3 plus 1. Now you can continue. The first thing I would do is find the period. I would find the period, and your 3 is going to be the period. However, that doesn't mean that your period is 3. You just use it to calculate your period. The period is 2 pi divided by that b value, which is 3. Now I'd label my x-axis just so it's done. Count out 4 units and write down 2 pi over 3. 1, 2, 3, 4, 2 pi over 3. Half, multiply by 3. 2 pi divided by 3 divided by 2 is just pi over 3. Pi over 3 divided by 2 is pi over 6. Pi over 6 times 3 is pi over 2. Now you don't have to worry about the period ever again. Unless you got it wrong and then you have to correct it. Practice that. Practice doing that on this homework. The faster you can do that, the easier it is when we change the period. All right, then we'll talk about the amplitude. Amplitude is just 2. It is going to go left pi over 3 units, and it's going to go up 1 unit. So 2 is our amplitude. This tells us to go right, and that plus 1 tells us to go up. So if you're using the sinusoidal axis, you can do it first. If you're not using the sinusoidal axis, you have to do up last. I'm going to go ahead and shift the sinusoidal axis up. It will save me. I like doing it that way because then I can just get rid of it. So I'm going to graph my sinusoidal axis first. That is up 1. All right, the next thing I take care of is the amplitude. I'm actually just going to graph a sine curve with the amplitude of 2. That's what I'm going to graph first. So a sine curve with an amplitude of 2 shifted up 1 would look something like this. Since my amplitude is 2, it'd be up that high. I'm sorry, it's sine, isn't it? It's not cosine. It should be at the origin of our sinusoidal axis. Because sine starts at 0, goes up, and then comes back down. So in this case, we start at 0, 1. Our amplitude is 2. So instead of going up 1, we're going to go up 2. We go back to the sinusoidal axis. We go down 2, and then back to the sinusoidal axis. So that is now a graph that shifted up with an amplitude of 2. So we went up, amplitude of 2. We took care of the period, so the only thing we have to do now is go right pi over 3 units. And we're done. So we just have to go right pi over 3 units. Well, that's right here. Shift all of our points basically to tick marks. So I'm going to shift this point here. I'm going to shift this point here. I'm going to shift this purple point here, this point here, and finally that point there. So go ahead and shift it right pi over 3 units. I'll make some kind of mark saying that's my final graph. That's the one that you should look at to grade. Who got lost when I did this one? A little bit?
Can you just repeat how you found the period?
Yeah. So how I got the 2 pi over 3 or how I actually made these numbers?
How you got the 2 pi over 3?
2 pi over 3 comes from, do you see this number right here? So the period is, the actual formula for the period is 2 pi divided by b. So you just have to know what that b value is.
Okay.
So if we look back here, that b value is that number that's out front. And it just happened in this case to be 3, so you just replace that b with 3. This is about as fast as you should graph this. You shouldn't skip any more steps in that. You shouldn't try to do every single transformation at once. In fact, if I'm starting off, I'm probably going to show a lot more than that. I'll probably show like a sine graph, then I'll probably shift it up, then maybe I'll do like an amplitude. So you probably want to show more than this. This is the least amount you should probably draw. All right, that's a sinusoidal axis, your amplitude drawn on top of it, and a shift. That should be as quick as you draw these. I shouldn't see a lot of, I'm going to jump straight to that. Because even if you can do that, you're wasting a whole bunch of brain power trying to keep track of points and where things are, and you're much more likely to mess it up and screw it up on the test, even though you know what you're doing. All right. Remember, a test is to show me what you know, not how quickly you can do stuff in your head or how much you can do in your head. In fact, the more you put on paper, the better scores typically people get, because I can see what you did. I can see where your mistakes came from. All right, questions for me? All right, the next one is homework, along with the rest of them. It's not a super long assignment. Look at the last 2 problems. Look at the last 2 problems. The last 2 problems, 41 and 43, ask you to actually come up with a function. So you're going backwards. Now let me just kind of describe what those numbers they give you are. So look at 41. It says pi, negative pi over 2, and 3 comma 7. Do we all see that? That is saying the period, and it does say this in the directions, but I'm reiterating it. The period is pi. So in other words, 2 pi divided by b equals pi. You've got to figure out the value of b. It is being shifted left pi over 2 units, so that means left. And the range is 3 to 7. So you know how they bounce between two numbers? Usually it's like positive 1 and negative 1. In this case, it's going to bounce between 7 and 3. So you got to figure out where your sinusoidal axis is to figure out your amplitude and how far up or down it's shifted. All right? So that 3 to 7 will tell you if it's shifted up or down and your amplitude. All right, you can go ahead and get started.